faster than the surface of room-time can remain mindful of it, and it'll essentially tear. I'm terrified by this. At this point, our night sky is evolving rapidly, and in an issue of numerous years, if not less, it could turn out to be absolutely unrecognizable. Cosmologists generally are sounding the caution. Experts like Neil deGrasse Tyson have as of late avowed the looming impact of Polaris, and the story behind it is exceptionally unnerving. Polaris, known as the North Star, has for quite a while been a study in our night sky, filling in as an imperative reference point for stargazers, pilots, and space specialists. Nonetheless, this could before long change, altering our night sky and cosmic estimations until the end of time. We ought to dive into the importance of this danger and its suggestions for all of us. Go along with us as we uncover the story of Polaris as it pushes toward its end. For quite a while, Polaris has directed mariners and stargazers the same, standing firm in a respected situation as a directing light. Its enduring presence in the night sky has been central for route. However, this strength may before long be upset. In September 2023, an exploration paper introduced by the regarded Imperial Galactic Culture cast uncertainty on the destiny of this grand illuminator. Polaris is really close to exploding, possibly dissipating from the night sky for eternity. Before we investigate the consequences of this exposure, we should dive deeper into Polaris, also called the North Star or Pole Star. Polaris is one of a kind because of its vicinity to the divine North Pole, situated straight over Earth's North Pole. It shows up nearly fixed in the northern sky, tracked down in the heavenly body Ursa Minor, or the Little Scoop. Polaris sparkles as a decently radiant yellow-white supergiant star, a lot bigger and more splendid than our Sun. It's anything but a solitary star, yet part of an intricate triple-star framework, with Polaris N and Polaris B shaping a twofold pair, while Polaris B circles around them. The collaborations among these stars make gravitational powers forming their circles and influencing their way of behaving. Any aggravations in these collaborations can prompt capricious varieties in the star's splendor or throb designs. In any case, the particular systems behind these cooperations stay muddled. Polaris is found about 323 light-years from Earth, meaning the light we see from it today started its excursion over 3 centuries prior. Thusly, if Polaris somehow managed to explode now, we wouldn't see it until over 3 centuries after the fact. It's even conceivable that Polaris has previously exploded, and we presently can't seem to notice the light from that occasion. Since forever ago, the North Star has held huge social, navigational, and representative significance. Its strength and fixed position made it a precious aid for old sailors, guiding them across seas and territories. Emblematically, Polaris addresses consistency and heading, staying immovable in the midst of the consistently changing night sky. For cosmologists, Polaris is filled in as a basic reference point, supporting the investigation of divine developments in factor stars. As a Cepheid variable star, its occasional varieties in splendor have given significant bits of knowledge into heavenly properties and the idea of variable stars. This trademark has likewise assumed a vital part in deciding galactic distances and aligning instruments. These throbs follow an anticipated example, which has been the norm for the star, making it simple for us to expect its way of behaving. In any case, as of late, Polaris has digressed from this typical way of behaving. This irregularity in its throb cycle has confounded cosmologists, provoking a nearer assessment of this heavenly quirk. As opposed to its typical unsurprising example, Polaris has started showing inconsistent patterns of darkening and lighting up. Specialists are presently raising worries that the star might be moving toward the finish of its life. This lines up with ways of behaving ordinarily saw in stars approaching their end. The sluggish extension of Polaris' throb period, which was once consistent, can be ascribed to associations inside its star framework. We have noticed a yearly expansion in the throb length of 4.5 seconds, which might appear to be minor yet holds huge ramifications. A few stargazers propose that gravitational cooperations between the Polaris stars could be causing these vacillations in its climatic circumstances, straightforwardly influencing its throb designs. Nonetheless, others are more frightened, accepting that the star is on the actual edge of detonating. The likenesses between Polaris' way of behaving and that of Betelgeuse, one more conspicuous star in the Orion heavenly body, are striking. The two stars have shown bewildering irregularities in their splendor, raising worries about possible blasts. Stars in their dusk organizes frequently show such irregularities prior to arriving at the pinnacle of their life cycles. While NASA has communicated elevated worry about Betelgeuse, comparable consideration has not been officially coordinated toward Polaris yet. As a Cepheid star moves toward the finish of its life cycle, it advances through different stages, including the primary grouping stage, red Goliath stage, lastly the cosmic explosion blast. In light of Polaris' sporadic throbs, scientists foresee it has entered the helium-consuming stages ordinary of Cepheid stars approaching their end. These irregularities in Polaris' way of behaving line up with designs characteristic of Cepheid stars in their nightfall stages. However, conclusive indications of its approaching cosmic explosion stay questionable. Cosmologists are perseveringly researching these errors to decide Polaris' destiny. If Polaris somehow managed to detonate, it would probably be a terrific occasion in our sky, possibly overshadowing the moon and becoming one of the most brilliant articles noticeable for days, weeks, or even months. Its appearance could drastically change, momentarily modifying our view of natural heavenly bodies like the huge Scoop or Ursa Minor, of which Polaris is a section. Have confidence, Earth would almost certainly be totally protected, regardless of whether Polaris were to explode, given its mass and distance from us. While a Polaris blast probably won't be outwardly as staggering as possible Betelgeuse, it may as yet be clear to the unaided eye for a drawn-out period, surpassing close-by stars. Space experts and observatories would without a doubt observe, lighting interest among standard researchers and stargazers around the world. Be that as it may, the particular perceivability and effect on Earth's climate would be less critical contrasted with a nearer cosmic explosion occasion. Yet, what might be said about Polaris itself? What will be its destiny after a potential cosmic explosion occasion? We should explain a certain something. While enormous stars frequently end their lives with a cosmic explosion, this is probably not going to be the situation with Polaris. At the point when a monstrous star goes cosmic explosion, a gigantic blast happens inside it, denoting the last devastating stage in its life. This interaction includes a total breakdown of the center, setting off a gigantic shockwave that makes the star detonate brutally. Nonetheless, Polaris isn't sufficiently enormous to go through such a blast. All things considered, when Polaris debilitates its atomic fuel, it will shed its external layers and develop into a white diminutive person. This progress won't bring about a cosmic explosion, yet rather a tranquil end as it turns into a little, extraordinarily thick heavenly remainder. A white midget is the leftover of a low or medium-mass star that has drained its atomic fuel. It's inconceivably thick, conceivably as gigantic as the sun yet packed to the size of Earth. At the point when this occurs, we will never again see its leftovers from our planet, like how we notice the star today. Taking into account the likely effects of Polaris destruction close by authentic cosmic explosion occasions gives huge experiences into the development of stars and their definitive destinies. Contrasting our assumptions and recorded supernovae like SN 1054 or SN 1987A, as well as later occasions, for example, SN 2011 Fe or SN 2014J, yield significant information for grasping the possible results of Polaris blast. SN 1054, for instance, brought about the development of the Crab cloud, a cloud that proceeds to extend and transmit radiation across different frequencies, furnishing stargazers with a rich field for study. Also, SN 1987A saw in the huge Magellanic Cloud offered bits of knowledge into nucleosynthesis processes and the elements of cosmic explosion leftovers. Breaking down peculiarities like the development of nebulae, the arrival of enormous beams, and varieties in brilliance can give experiences into Polaris novel attributes. The arrangement of nebulae like the Crab cloud results from the ejection of material during the cosmic explosion blast, communicating with encompassing interstellar gas and residue, enhancing it with weighty components and adding to the pattern of heavenly birth and demise. Besides, the arrival of enormous beams, high-energy particles sped up quickly by cosmic explosion shock waves, has suggestions for astrophysical cycles and astronomical radiation conditions. To lead a convincing examination, scientists evaluate contrasts in mass, structure, and speed of launched-out materials between Polaris likely blast and other noticed occasions. This includes concentrating on the light bends, spectra, and leftovers from these occasions, extrapolating comparable attributes for Polaris likely blast. Assessing whether Polaris blast could prompt the arrangement of nebulae or outstanding essential dispersions improves how we might interpret its likely results. One more essential area of examination includes surveying the pulsational inconstancy of stars approaching their end stages, similar as Polaris, against noticed cosmic explosion begettas. This relative review can assist with recognizing similitudes or deviations and give bits of knowledge into the blast components. Pulsational changeability in stars moving toward the finish of their lives might demonstrate inner hazards or looming disastrous occasions, offering hints to the transformative cycles prompting cosmic explosion blasts. Notwithstanding fastidious perceptions and broad examination, space experts end up baffled by the irregularities saw in Polaris' way of behaving. Unwinding the exceptional conditions driving these oddities holds the way to propelling comprehension we might interpret heavenly advancement. Understanding the components liable for Polaris' unpredictable throbs requires interdisciplinary coordinated effort and the improvement of cutting-edge hypothetical models and observational methods. The likely loss of Polaris as a critical reference point in the night sky presents huge worries for cosmic undertakings. Ground-based telescopes and divine estimations would require recalibration, influencing the precision of galactic assessments. The shortfall of Polaris could likewise influence route frameworks and social practices dependent on heavenly milestones, featuring the meaning of this divine occasion. The intricate way of behaving showed by Polaris highlights the requirement for more profound examinations and committed research endeavors. Cosmologists should wrestle with the complexities encompassing its capricious throbs and present significant responses,